Let's look at more on this fundamental theorem of calculus, but see how can it be actually applied. How could we actually use this given a rate and finding area underneath it? All right, so the first example here says a forest fire is covering or covers 2015 acres at a time t equals 0. Okay, so at the very start of time, it's already, the forest fire has already covered 2015 acres. All right, the fire is growing at a rate of, this is the important part because this tells you this is what you're graphing. This is my actual derivative, my rate. And it says where this is in acres per hour. So there's my units. How many acres are covered during 24 hours later? So what I'm trying to find is this point, of course, right here is going to be 24. I'm trying to find this area underneath here because what this area underneath here will actually give me is acres. Okay, so remember that the actual rate is in acres per hour, but what I'm looking for is the actual acres. So I know that I want to find from 0 to 24, because it says 24 hours later, based off of this rate in terms of my variable t. Okay, so this is what I'm trying to solve. What I probably would do is pull the 8 out front. And then I know I'm going to need to use the power rule, so I'm going to make the square root the 1/2 power. Okay, so that gives me 1/2 power. And now from here, I can actually use my power rule that says this would become t to the 1/2 plus 1 over 1/2 plus 1. And this is what I'm going to be evaluating from 0 to 24. All right, and so from here, I can simply say, well, this is going to end up being 8 still out front, t to the 3/2 over 3/2. And you're going, how in the world did you get that? Well, hopefully you kind of sort of remember adding 1/2 plus 1, you have to get common denominators. So that's how I'm getting that 3/2 value. All right, and now from here, you just simply pick up your calculator and you plug everything in. There are, things that you could do. You could move this up here and make it 16 over 3, but I kind of leave that up to you. Some of you will just pick up your calculator. But remember what you're doing. You're doing f of b minus f of a. And so in this example, you're doing f of 24 minus f of 0. And once you work that out, you will get a value that I want to see what you get. And then notice it says how many acres are covered 24 hours later. You're going to take whatever answer you get and you're going to have to add it to how many acres have already burned. So be sure you finish that one up and get me an answer. All right, let's look at another example. All right, next says water is pumped out of a holding tank at a rate. So you already know that this is this function graphed. That's my derivative in liters per minute, where t is in minutes since the pump started. If the holding tank contains 1,000 liters of water when the pump started, how much water does it hold 1 hour later? So that tells me I'm going to find how much was pumped out and take 1,000 minus it. Okay, because that's how much it had from the beginning. So again, starting out, I know that this is a rate, 7 minus 7e to the negative 0.12. That's kind of horrible looking. Let me see if I can make that a little better. 1 to t, and of course with respect to the variable t. This is when I actually, and let me get my interval here. So notice this is in minutes and it wants to know how much water does it hold 1 hour later. So 1 hour later would be from 0 to 60. Now this is one I probably would separate, meaning I would go from 0 to 60, 7 with respect to t, and then 0 to 60, 7e to the negative 0.1 to t dt. So all I did is I thought, well, this might be a good idea to separate these and do the integrals, okay, end up doing the integrals here individually. All right, so this first piece right here, hopefully you know we've talked about already this constant. The antiderivative of 7 is 7t, and so that's going to be from 0 to 60, minus, so this is that minus right there. I have a 7 out front, and this piece right here is that 1 over k, where k in this case is negative 0.12, and then the e part just simply stays the same. 1 to t, and I'm evaluating that from 0 to 60. All right, now I'm ready to use my whole f of b minus my f of a, but I have two groups to do it in. So the first one, my first group here, okay, let's say this is my first group, is going to be 7 times 60, that's my upper value, minus my lower value, 7 times 0, all right? And then minus, that minus right there, I definitely would put all of this in square brackets so I don't lose that negative sign. And so from here, I'm just going to write the 7 over negative 0.12. Okay, that's just, I just brought that inside here. E raised to the negative 0.12 times 60. So that's this f of b. I'm going to put this piece in parentheses, and now I'm going to do my f of a, which again is 7 over negative 0.12 e to the negative 0.12 times 0, and then close off my bracket.